Hello and welcome to our JAMB UTME prep series, where we provide relatively detailed solutions and explanations to the JAMB UTME questions. In this recording, we are looking at the JAMB UTME physics for the year 2020, and this is the first part where we're looking at the first 20 questions out of 40 questions for the year 2020. Okay, so these questions are selected questions for this year 2020. Now, before we continue, don't forget to subscribe to our channel, like and share our videos, our content, and you can also visit our website collab.com for UTME study and practices. Alright, the first question: a few grains of table salt were put in a cup of cold water, kept at constant temperature and left undistributed. Eventually all the water tasted salty. This action is due to, we have convection, osmosis, capillarity, and diffusion. Alright, so what happens is the grains of the salts, okay, at first they will settle at the bottom of that cold water, of that cup of cold water, but later they begin to dissolve, and when they begin to dissolve, ions of that salt will begin to move from that lower part, that region of higher concentration, which is the bottom of the cup. It will begin to diffuse, okay, gradually to regions of lower concentration, that is the upper part, okay, until there is an even distribution and all the water will taste salty. So the correct option here would be diffusion. The second question: the force required to make an object of mass m traveling with velocity v turn in a circle of radius r is, the first option, mv squared over r, mr squared x, mrv, mvr squared. Okay, so when we have a body in circular motion, a body undergoing circular motion, there are two forces acting on that body, okay, that is the centripetal and the centrifugal force. These are the two forces these two forces are of equal magnitude, but they are oppositely directed, and they act in such a way that they keep that body moving in that circular path. Now, the centripetal force is given by mv squared over r, where m is the mass of the object, v is the velocity of the object, and r is the radius of the circle in which that object moves. So we have mv squared over r as the correct. Next question: a machine gun with a mass of 5 kg fires a 50-gram bullet at a speed of 100 meters per second. The recoil speed of the machine gun is, the options, 0.5 meter per second, 1.5 meter per second, 1 meter per second, 2 meter per second. Alright, so this is a question related to the laws of motion, especially the third law of motion, okay, which states that action and reaction are equal and opposite, or to every action there is equal and opposite reaction. So what happens is, when a bullet is fired, okay, the proportion of that bullet is an action, there will be a reaction on the gun itself, okay, and the momentum of the gun would be equal to the momentum of the bullet. Now, momentum is the momentum of a body is equal to the mass of the body times the velocity of that body. So the momentum of the gun is going to be the mass of the gun times the velocity of the gun, while the momentum of the bullet will be the mass of the bullet times the velocity of the bullet. Now, in the question, they already gave us the mass of the gun here as 5 kg. The mass of the bullet is given as 50 gram. Now we need to balance the mass here. The mass of the gun is in kilogram, mass of the bullet is in gram. We need to convert the mass of the bullet to kilogram, okay, and in converting from gram to kilogram, we divide by 1000. So to get the mass of the bullet that would be here, we divided the mass of the bullet, which is given here as 50 gram, we divided it by 1000. 50 divided by 1000 will give you 0.05, okay. Then multiply this by the velocity of the bullet, which is 100 meters per second. Now when you multiply this, you're going to have 0.05 times 100, that will be 5, so this side will be 5, and then 5 times vg, that is the velocity of the recoil velocity of the gun, that's going to be 5 vg. Then dividing both sides by 5, we have the velocity of the gun to be equal to 1 meter per second, okay. So that is the correct option. Next question: on wave, if in a simple pendulum experiment the length of the inextensible string is increased by a factor of 4, its period is increased by a factor of, okay, so we know that the period T varies directly as the square root of L, okay, and the period of a simple pendulum is given by this formula here. The period T is equal to 2 pi root L, the length of that string, over the acceleration due to gravity. Now if the length, okay, is increased by a factor of 4, what that means is that the length is now multiplied by 4. It is now quadrupled. That means that the new length Ln, let's denote that as Ln, is going to be equal to 4L. Excuse me, it will be 4L. That is 4 times L. And so the new value of the tension T, let that be Tn. Okay. Now T originally here is 2 pi root L over G, but Tn, that is the new period now. Remember that the length has been increased by a factor of 4. That means that the new length is now 4L. It's not 2L. It's not L. It's now 4L. Now, if we take the square root of this 4 here, we are going to have 2 right here. We have 2 right here. So that means I have 2 pi times 2. Now I can rewrite this as 2 times 2 pi root L over G. Then we call here that the tension rather, the period, excuse me, the period originally was what? 2 pi root L over G. So meaning this 2 times 2 pi root L over G becomes 2 times this value here is for what? For the original tension. So that means that the new tension is now 2 times the original tension. So what does this mean? Is that if the length of the string is increased by a factor of 4, then its period will be increased by a factor of 2. That means the period would double. Okay, the period would double. Alright. Next question. In what range of temperature is expansion of water anomalous? In what range of temperature? Okay, anomalous, the term anomalous means abnormal, okay, or unusual. Now usually liquids and solids, when they are heated, they expand when they are heated, and when they cool, they contract. Expand meaning they increase in size, and when they cool, they contract, that is they reduce in size. Okay, this is what is expected. However, in the case of water, okay, it has an abnormal expansion when the temperature falls from 4 to 0. When the temperature falls, meaning the body is cooling, okay, it is losing heat, it is cooling, it is supposed to contract. But however, water, when the temperature falls from 4 degrees Celsius to 0 degrees Celsius, instead of contracting, instead of becoming smaller, it expands. Okay, it expands, it turns into ice. Okay, so it expands. That is an anomalous behavior. Okay, so the anomalous expansion of water occurs when you have water between the range of 0 degrees Celsius to 4 degrees Celsius. 0 degrees Celsius to 4 degrees Celsius. Option C. Question 6 is related to nuclear physics, radioactivity. Which of the following statements about radioactivity is true? I, the alpha particle, is positively charged. II, beta particle, is negatively charged. III, gamma ray, is neutral. IV, beta particle, has the same mass as helium atom. And V, gamma ray, is charged. Alright, so during radioactivity, when an atom, and every atom undergoes radioactivity, so some radiations are released, and that is the alpha particle, the beta particle, and the gamma rays. Now the alpha particle is positively charged, which is why it is attracted, okay, to a negative charge. Okay, the beta ray is negatively charged, it's an electron, it is negatively charged. The gamma ray is neutral, it carries no charge, it is neither positive nor negative, which is the reason why it does not get deflected or attracted by a magnetic field or an electric field. So I is correct, II is correct, and III. IV is wrong. Beta particle has the same mass as helium atom. That is wrong. The helium atom, in fact, is the alpha particle. Okay, the alpha particle, and the gamma ray is neutral. It is not charged. So you have III and III as a correct statement here. So that makes option B. Question 7. In the study of physics, temperature and heat are often confused with each other. Which of the following statements correctly defines these two elements? So this question is related to heat and temperature, or heat calorimetry. So the first statement, that temperature is a measure of the average kinetic energy of the molecules of a substance, that is correct. Okay, we say temperature is a measure of, we can say it is the degree of hotness or coldness of a substance. We also say that it is also the measure of the average kinetic energy of the molecules of a system, okay, or a substance. So the greater the average kinetic energy, the greater the temperature. Also, heat is a measure of the total kinetic energy of the molecules in a system, that is also correct. Different materials require different amounts of heat to cause a given change in temperature. This is true as well, okay, that every material has a unique heat capacity, and what that means is that if you supply the same heat, the same amount of heat to two different substances, okay, the temperature change in those two different substances may not be equal. Okay, we may find out that the temperature change in one of them might even be multiple of the temperature change in the other, okay, because the amount of heat that it takes to get a unit change in temperature in different quantities varies. Okay, so basically different materials require different amount of heat to cause a particular change or a given change in temperature. So all of the options here, all of the above is correct. So that means option D, the correct option here. All of the above is true of temperature and heat. Alright, the next question is on electricity. The question is, what is the effect? The effect of closing the key K in the circuit shown in the figure above would be to. So the question is, if the key here is closed, the key K here, if it is closed, what is going to happen here? Now, if the key is open, if the key is not closed, what happens here is these two resistances, they are connected in series. These two resistors, they are in series. So we have the 8 ohm resistor connected to the 2 ohms resistor, okay, in series, and the two of them are connected to a source here, okay. The potential difference here is 6 volts, right? 6 volts. Okay, so what we do here is this: we want to find out what is the current in this circuit now, okay, when the key is open. So what we do is find the total resistance. Now, since both of them are in series, we can simply add up the resistance. Just say 8 ohms plus 2 ohms. So that means the total resistance here in series is what? Is 10 ohms. Then from Ohm's law, we have it that the potential difference V is equal to IR, that is the current times the resistance. The resistance here is the total resistance that we just calculated here, while this V here is the potential difference of the circuits, okay, what we have here, right? So if we substitute that, V is 6, right, and our resistance is 10, so we have 10 times I, that's 10I. To get the value of I here, we divide both sides by what? By 10, and that will give us 0.6 ampere. That means that the current in this circuit currently, okay, the current in this circuit with this key open is 0.6 ampere. However, when this key is closed, something will happen here, and that is that the resistance in this region here is going to change. We are going to have a new effective resistance now. Why? Because when this key is closed, then these two resistances, this 8 ohms and this 8 ohm, they will both be connected in parallel, right? So we need to find the effective resistance for this parallel connection first. So how do we do that? When we have resistance connected in parallel like this, say two resistance connected in parallel, then the effective resistance, we say it is equal to 1 over R, right? 1 over Rp, where this Rp is the effective resistance in parallel, it will be equal to 1 over R1, that is one of the resistance, which here is just 8, plus 1 over R2, that is another 8, since these two resistances are 8 ohms, okay. So then we take the fraction, we take the LCM here, 1 over 8, the LCM here is 8, right? Then 8 in 8, that is 1 times 1, we have 1, plus 8 in 8, 1 times 1, we have 1 here, right? So 1 plus 1, we have 2 over 8, and this will be 1 over 4. So when we cross multiply here, then we're going to have the resistance in parallel to be equal to 4 ohms. That means that the effective resistance there now is 4 ohms, and that 4 ohms resistance will now be in series with this 2 ohms resistance. So the total resistance now is going to be the 4, that is the effective resistance there, which is 4, plus this 2, which is what, 6, right? Then we go back to the formula here from Ohm's law. V is equal to IR. So say V is equal to IR, where our V is 6 and our R, that is the new total resistance, is what, is 6. This is when the key is closed. Okay, so to get the value of I here, we divide both sides by 6 and we have I to be equal to 1 ampere. So the current now, the new current now is 1 ampere. So meaning when the key is closed, the current in this circuit is 1 ampere, but when it is open, the current is 0.6 ampere. So if we take the difference in the current now, that will be 1 minus 0.6, and that is 0.4 ampere. Now since the difference in the current is positive, what this means is that closing the key here will bring about an increase, okay, in the current, because the original current, the initial current when the key was open was 0.6 and the current now is 1. So that means there's an increase now in the current. So that makes the correct option here option. We have our website at collab.com where you could practice exams for free, the UTME exam and the post-UTME exam. It also features modular quizzes in physics, chemistry and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at collab.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. Freebies are also available to top performance on the website. The next question is on the electromagnetic spectrum. Which of the following statements on the use of X-rays is incorrect? So we have X-rays are used. We have option A, in a hospital to obtain photographs of tissues and bones in the body. B, for the treatment of malignant growths like cancer cells. C, in detecting fingerprints. And D, to reveal hidden flaws in metal castings and wielded joint work of art. So X-ray is an electromagnetic radiation and it is used in all of the options except in the detecting of fingerprints. It is not used in detecting prints. Next is on work, energy and power. Under which of the following condition is work done? So the point here is, when do we say that work is done? Work is done when a force is applied on the body over a distance. Okay, when the force is applied on a body over a distance. That's why we have work done to be equal to the force applied times the distance, okay, the distance in the direction of the force in which that body is moved. So if we consider the options that we have here, the first one, a boy pushes onto a table. B, a boy stands on a table. C, a woman supports a heavy food above a man supports a heavy food above his head with his hands. And D, a woman holds a pot of water. So the question here is, in which of those following is force applied over a distance? And that is only in the first case, where we have a boy pushing onto a table. So you have a boy pushing a table over a distance, right? Like pushing a table from one point to another. So in this case, a force has been applied on the body and that body has been moved. Okay, there's a change in the position of the body. But in the other stage, you can see that there's a kind of the subjects there are kind of stationary. For example, a boy standing on the table, a man supporting a heavy food above his head, and it's just stationary there. And a woman that holding a pot, that's stationary. So yes, we can say that there's some sort of force, right? Yeah, but there is no we can't see the application of the force over a distance in this case. Question 11. Natural radioactivity consists of emissions. You have alpha particles and beta ray, alpha particles and X-ray, gamma ray and X-ray, alpha particles, beta rays and gamma rays. Right. So radioactivity is the disintegration of an unstable nucleus, and when this happens, three radiations are produced: alpha particle, beta particle and gamma rays. Okay, also in the process, energy is also liberated. So the emissions here are alpha particle, beta particle. Question 12. If a source of sound is moving, a stationary listener will hear a sound of different frequency. This is called Doppler effect. The Doppler effect is the perceived change in the frequency of a wave in relation to an observer that is moving relative to a wave source, okay, or a stationary observer, okay, relative to a moving wave source, right? That is called Doppler. Question 13 is on electricity. Which of the following can be described as high tension transmission? So high tension transmission with power lines occurs at low current and high voltage. That is what is characteristic of high tension transmission. So electricity is transmitted, okay, from the source over a long distance at high voltage and low current. Low current, why? Because this is to prevent the overheating of the wire or the coil. So you have low current and high voltage. Right, the next question is on electricity. What is the cost of running 550 watt lamps and 400 watt lamps for 10 hours if electrical energy costs 2 kobo per kilowatt? Alright, so what we need to do here first is calculate the total power that is consumed by these devices. Now we have 550 watt lamps, that is 5 lamps, each is rated at 50 watts. So the total power that will be consumed, the power of one lamp here is 50 watts. So for the 5 lamps, we're going to have 50 times 5, that's 250, right? 5 times 50, that's 250. While for the 400 watt lamp, you're going to have 4 times 100, that is 400, right? So we have 250 plus 400, and that is 650 watts. Then we convert that watt to kilowatt. Okay, we convert it to kilowatt, and in converting to kilowatt, that means we divide by 1000. So you have 650 divided by 1000, and that is equal to 0.65 kilowatts. So the total power that is consumed here is 0.65 kilowatts, right? The next thing that we do is to calculate the electrical energy, okay, the electrical energy here, which will be equal to the power times time. Now we have calculated the total power consumed there as 0.65 kilowatts times the time. The time in the question, they said the 4 lamps, these lamps, they run for 10 hours. So we are going to have 0.65 kilowatts times the time, which is 10. So 0.65 times 10 will be equal to 6.5. Then we have kilowatt hour. So this is the total energy that is consumed. Now 1 kilowatt hour is equal to 2 kobo, right? 2 kobo. 6.5 kilowatt hour would mean 6.5 times 1, right? 6.5 times 1 kilowatt hour, right? 6.5 times 1 kilowatt hour will give you 6.5 kilowatt hour. Now 1 kilowatt hour here, we said it is 2 kobo, right? From the question, they said 2 kobo per kilowatt, meaning 1 kilowatt hour is 2 kobo. It's charged at 2 kobo. So what do we do? This 1 kilowatt hour is what? 2 kobo. So 6.5 kilowatt hour becomes 6.5 times 2, and this will be equal to 13 kobo. Now looking at all of the options that we have here, the options are given in naira, but what we have here to begin with is kobo. So what do? We convert this to naira, and in converting from kobo to naira, we divide by 100. So 13 divided by 100, that gives you 0.13 naira. So that means the cost here is going to be 0 naira 13 kobo. 0 naira 13 kobo. You can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2, or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to have the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, you could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at collab.com, or you could also check it out in the video description below. Next, this question is on atomic physics, nuclear physics. The mass of a proton is approximately equal to that of... Okay, we know that in an atom there are 3 subparticles: the proton, the electron, and the neutron. So excuse me, the proton and the neutron are both located in the nucleus, while the electron is located in the shell, or what we call the electron cloud. Now, the electron is the lightest of particle of the atom. In fact, it is the proton is over 1,800 times heavier than electron, which is the reason why electron does not even account for the atomic mass of an atom. However, if you look at the mass of proton, this is 1.6 times 10 raised power minus 27 kilogram, while that of neutron is 1.68 times 10 raised power minus 27 kilogram. So you could say that the mass of a proton is about the mass of an electron. Next is on electromagnetism. A transformer has 300 turns of wire in the primary coil and 30 turns in the secondary coil. If the input voltage is 100 volts, the output voltage is. Alright, so what we do here is we're going to set up a ratio. The EMF, okay, the ratio of the EMF in the secondary to the EMF in the primary coil is equal to the number of turns in the secondary over the number of turns in the primary. Now from the question, we have the EMF. So when we cross multiply here, that is this and this, we are going to have the EMF in the secondary times the number of turns in the primary to be equal to the EMF in the primary times the number of turns in the secondary. Now the number of turns in the primary from the question is 300. So we have EMF, that is EMF in the secondary coil times 300 equals the number of turns, okay, in the secondary, this, which is 30, times the EMF in the primary, okay, this EP here, that is 100. So 30 times this is 300, 3,000. 300 times ES, that's 300 ES. Divide both sides by 300, and we have the EMF in the secondary to be equal to 10 volts. Next, a solid weighs 4.8 grams in air, 2.8 grams in water, and 3.2 grams in kerosene. The ratio of density of the solid to that of the kerosene is, we have option A 2, B 23, C 20, B 32, C 23, and D 3. Alright, so what we need to do here first is excuse me, let us look at the information that we are given, okay, from the question. So the mass of the solid in air is 4.5, as we have it here. The mass of the solid in water, okay, solid in water is 2.8. Mass of the solid in kerosene is 3.2. So what we are going to look at is what is the mass of the displaced kerosene. That will be equal to the mass of the solid in air minus the mass of the solid in the kerosene. That's 4.8 minus 3.2, and that is equal to 1.6. The next thing we are going to do is we are going to find the density of the solid, okay, and the kerosene in terms of their unspecified volume. Now what happens is this: when we suspended the solid in that kerosene, okay, some of the kerosene will be displaced. Now the volume of the kerosene that is displaced is going to be equal to the volume of the solid that was suspended in it. That is, for example, if you throw a solid into, let's say, a cup of water, if you watch closely, you realize that there will be a rise in the level of the water in that cup. The level of water is going to rise the moment you immerse that solid in it. The volume of that water, okay, the volume of water that has risen, that has been displaced there, is equal to the volume of that solid that is going into it. So the volume of the kerosene that is displaced is equal to the volume of the solid, okay. So now recall that density is given as the mass of the object over its volume. So the density of the solid is going to be the mass of the solid divided by its volume, and that will be equal to the mass, which is 4.8, that's mass of the solid in air, over its volume, which is denoted as V. Okay, so we have the density of the solid to be 4.8 over V, while the density of the kerosene is going to be 1.6 over, that is volume of the density of the kerosene, that is, we're looking at the one that is displaced here, okay, is going to be the mass of the kerosene displaced, that is 1.6, which we got from here, divided by the volume of the kerosene displaced, which is V. Finally, the ratio of the density of the solid to that of the kerosene is going to be 4.8 over V divided by 1.6 over V. Now because we have this V on the same side, right, like at the denominator, okay, it is at the denominator here, it's at the denominator here, we can cancel out the V, and so we'll be left with 4.8 divided by 1 point option. Question 18. One of the following readings represents the measurement of the length of a metal rod using vernier calipers. Taking the reading accuracy into consideration, the most likely one is, we have 5.16, 5.165, 5.0, 5.160. The reading accuracy of a vernier caliper is 0.1 millimeter or 0.01 centimeter. What that means is that the vernier caliper can measure up until 0.x, like 0.0x centimeter. So it can measure up until, like, say 0.01, 0.02, 0.03. Now, looking at the options that we have here, this is 5.160. That is even more than like 2 decimal places. That's like 0.000, okay, which is beyond the reading accuracy of the vernier caliper. So you cannot get this reading with a vernier caliper. And 5.0, you can get a more accurate reading than this, right, with a vernier caliper, okay, because you can still have like 0 something right there, like 2 decimal places after the we can still have this figure to 2 decimal places, while here to 3 decimal places, that is above the reading accuracy. Okay, you cannot read anything beyond 0.0x centimeter with a vernier caliper. You could do that with a micrometer screw gauge. Okay, so you can have this reading with a micrometer screw gauge. So the correct reading here is just 5.16, because this is up until, say, 0.06 centimeter. So it is still very much within the reading accuracy of the vernier. Next, when a sound wave passes from air into water, what happens? Okay, so when a wave moves between two media, the frequency of that wave is going to remain constant. Okay, it will remain the same, it will not change. So the only thing that may change, or that will change, that would usually change, is the speed and the wavelength. Now for sound is a mechanical wave which requires a material medium for its propagation, meaning that in order for sound wave to travel through a medium, then vibrations have to be transferred from one particle of that medium to another. Now, if you look at air and water, the molecules, the particles of air, they are more loose than that of water. Okay, what that means is that it will take a longer time, right, for vibrations to be transferred between particles of air, particles in air, right, but it will take a lesser time in water. So what that means is that the speed of sound in water is going to be faster, right, because the particles are closer than in air. Okay, and so it is easier for the vibration to pass through, right, to be transferred between them. So the speed and the wavelength would increase, but the frequency of the wave will remain the same. Okay, option. Alright, the last question for this part. A convex mirror is used as a driving mirror because its image is erect, it has a large field of view, it has a long focal length. So this question is on optics and light ray. Alright, so the image produced by a convex mirror is erect. Okay, it is erect, it is virtual. Also, the convex mirror gives a wide range of view, meaning that it is able to cover a larger field of view, right, a larger field of view, which is the reason why it is used as a driving mirror, so you can see more things behind. However, the focal length of the mirror actually depends on the curvature of the material from which it was made. Okay, so the focal length, for example, is half the radius of curvature, right, half the radius of curvature. So the greater the curvature, the greater the focal length, right, because the greater the radius of curvature, so the greater the focal length. So we cannot say, like, generally that it has a long focal length. This depends on the curvature of the material. So I is correct that the image is erect. Okay, it is virtual as well. Also that it has a large field of view, that is it covers a wide range of view. So I and I are the correct options. Okay, don't forget to check out our playlist. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry, and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam and also for crash courses in physics, chemistry, and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at Collab. Okay, like and share our content, and visit our website at collab.com to practice UTME exam and modular quizzes for free. Thank you.